voice agent project, I ran into a slightly annoying problem. The agent could hear its own voice through the speakers. That meant it could accidentally transcribe itself, or I had to mute the microphone whenever it spoke. So muting worked, but it also meant I couldn't interrupt the agent. Conversation felt less natural, and so I needed to add Acoustic Echo Cancellation, or AEC. I'd like to note that if your voice agent interacts via web UI, you can use WebRTC, which also includes AEC. When you're building a local voice agent or one that doesn't use WebRTC, then you must handle the echo cancellation yourself. So here's what it changed and how this looks like. This is a really long sentence which I hope will not echo back to me.
This is a really...
Okay, let me try again and see if it gets through this new sentence.
Okay,
Maybe a shorter sentence will go through.
Maybe a short...
Now this is a really long sentence. Whether it will go through or not, I don't know.
Now this is really long sentence. Whether it will go through or not.
Wow, that's perfect.
Wow, that's perfect.
Looks like the echo cancellation is working.
Looks like the equal cancellations were.
The basic idea behind echo cancellation is quite simple. AC receives two audio signals. The first is the microphone signal. It contains my voice, background noise, and the echo coming from the speakers. The second signal is the exact audio that is being sent to the speakers. This is generated by, say, a TTS engine, text-to-speech engine, prompted by a LLM output. That's called the second signal is called the reference signal. What AEC does is to compare the two signals and estimate how the speaker audio traveled through the room back to the mic, and then removes that echo from the microphone in. After the AEC, we get the clean audio that can continue to the rest of the pipeline, voice detection, transcription, and so on. So correlating and comparing the two signals is the real hard part, which involves clever algorithms. Okay, so how did I add AEC to mulive? First, what changed in the architecture? Originally, mulive handled the microphone input and TTS playback through separate audio streams. The microphone pipeline had no exact reference for what was playing to the speaker. Without that, the echo can't be cancelled away. So to add back the reference together, I changed this to a full duplex audio path that handles microphone call capture and speaker playback together. So now every speaker frame is also passed to the echo canceller, the AEC module, and then the clean microphone audio reaches voice detection. Besides the core architecture change, I realized that there are many more nuances that need to be handled. So there are three other implementation challenges. The first one is the generated speech and the microphone use different sample rates. So Kokoro, which was my TTS module, produced audio at 24 kHz while the AEC pipeline ran at 16 kHz. So I added a real-time resampling, and you would have to add it depending on how your two different sample rates differ. Second, the echo cancellation needs small synchronized audio frames. The input to AEC are small 10 millisecond chunks. That gets the AEC working correctly, but then down the stream, the voice detector VAD module works better with larger 200 millisecond chunks. So after cleaning each 10 millisecond frame, I collected 20 of them, buffered them into 1 to 200 millisecond window. That was passed to the voice detection module. This kept the AEC responsive without disturbing the existing speech pipeline. Let's look at some code quickly. The key module is the audio processor module from PyWebRTC Audio Library. PyWebRTC Audio is what I used here, but there are other options like voice clean also. For every audio callback, I pass it the microphone frame and the matching speaker frame. And the clean audio then continues to VAD. Most of the surrounding work was about delivering these two synchronized frames safely and consistently. Another hurdle, AEC also needs to account for the small delay between playing the audio and hearing its echo to the microphone. So I added a delay setting that can be tuned for different microphone speakers and audio devices. Default is 40 milliseconds. It's also a no AEC option. Finally, I add tests for buffering, resampling, and interruption handling, and test the setup using physical speakers and a mic on my MacBook. So that's a quick overview of how to add echo cancellation to prevent voice agent from hearing itself. Adding AEC turned out to be pretty nuanced. It isn't just a single function call. You need the exact speaker audio, synchronized mic frames, and buffering to bridge with the rest of the voice pipeline. But once those pieces are connected, the result is a local voice agent that is actually usable and can keep listening without hearing itself. The full implementation code is open source in the mulive repository. If you're building a local Python voice agent, the same architecture can help you add real interruptible conversation. I'll discuss that in another video. For more insights on how to engineer real voice agents, do subscribe and check out my other videos.